mathematicians, it's Justin again. I am loving my new pool. My friend Anthony came over and we had an epic swim race. We timed each other with my stopwatch, and now we just need to compare the times to see who won. My time was 5.9 seconds, and Anthony's was 5.7 seconds. Who was faster? A number line can help us compare numbers. Smaller numbers are to the left, and larger numbers are to the right. Here, we can see that 5.7 is smaller or less than 5.9. Writing this as an inequality looks like this. Since Anthony's time was smaller, that means he won. I guess I need to keep practicing to get faster. But this got me thinking. We've been working with irrational numbers lately. Can we compare them the same way we compared our swim times? Let's try comparing the square root of 33 with the square root of 35. We'll need to use what we know about square roots to figure this out. Pause the video and write down 3 things you know about square roots in your guided notes. Great! Now that you've refreshed your memory about square roots, let's think about the 2 we have here. Are 33 and 35 perfect squares? Nope. So their square roots are irrational numbers. Even though their decimals go on forever, irrational numbers are still numbers, so we can compare their values. Which do you think is smaller? Remember, a square root is a number that, when squared or multiplied by itself, equals the original number under the radical. So which is smaller? A number that squares to 33 or a number that squares to 35? Since 33 is smaller than 35, the number that squares to 33 must be smaller than the number that squares to 35. Pause the video and use this information to write an inequality comparing the 2 numbers. The square root of 33 is less than the square root of 35. When we're comparing principal square roots, the smaller square root has the smaller number under the radical. Next, let's try comparing an irrational number with a rational number, the square root of 38 and 5.9. Since only one of these numbers is a square root, we'll need a different strategy. 38 isn't a perfect square, so it's hard to tell how its value compares to 5.9. If we knew what whole numbers the square root of 38 was between, maybe we can compare them more easily. Which 2 whole numbers do you think the square root of 38 is between? Pause the video and write them in your guided notes. 6 squared is 36, that's smaller than 38, and 7 squared is 49, that's bigger than 38. Let's use this to help us. We could write an inequality to show that 38 is between 36 and 49 using 2 less than symbols. Since 38 is the main number we're comparing in this inequality, we can read it from the center. This shows that 38 is between 36 and 49 because it's greater than 36, but less than 49. It's a great way to show both comparisons in one statement. Now, we can use what we just learned about comparing principal square roots and the numbers under their radicals. How should we order the square roots of these numbers in this inequality? Just like before, the smaller number under the radical has the smaller principal square root, so the square roots are in the same order as the original numbers. From here, we can evaluate the square roots of 36 and 49 to see that the square root of 38 must be between 6 and 7. So what does this tell us about how the square root of 38 and 5.9 compare? On the number line, the square root of 38 is somewhere between 6 and 7, and 5.9 goes here. Which number is smaller? Even though we don't know the exact value of the square root of 38, we do know that all the numbers between 6 and 7 are greater than 5.9. This means the square root of 38 is greater than 5.9. Let's try a few example problems to practice comparing with irrational numbers. Compare each pair of numbers by writing an inequality symbol in the blank. You can plot the numbers on a number line to help you out. Pause the video to complete these in your guided notes. 7 halves is the same as 3 1/2, or 3.5. The square root of 8 is between 2 and 3, because 2 squared is 4, a little smaller than 8, and 3 squared is 9, a little bigger. On the number line, we can see that 7 halves is greater than the square root of 8. In the next pair, did you notice that we're comparing a positive number to a negative number? Can a positive number ever be less than a negative number? No, we don't even need to estimate how big the square root of 26 is. Since it's positive, we already know that it's greater than -5. For the third pair, both numbers are negative. We can approximate where -7.239 ... is on the number line. It falls just to the left of -7.2, somewhere around here. For the negative square root of 68, we can use the same strategy as before. The square root of 68 is between 8 and 9, because 8 squared is 64, and 9 squared is 81. But since we have the negative square root of 68, we just change positive 8 and 9 to negative 8 and 9. So the negative square root of 68 is between -8 and -9. Be careful here. You might think 8 and 9 are bigger than 7.239 ... but since these are negative numbers, that changes. The negative square root of 68 is farther left on the number line, so it's less than -7.239 ... Now that we've practiced comparing two numbers, let's try comparing 3. Use the same strategies we used to compare two numbers to order these 3 numbers from least to greatest. Again, you can plot them on a number line to help. Pause the video here to try this in your guided notes. The square root of 84 is between 9 and 10, because 9 squared is 81, and 10 squared is 100. We can place 8.731 ... at around 8.7. And what about the square root of 121? 121 is a perfect square, and its square root is 11. Looking at the number line, 8.731 ... is on the left, so it's the smallest number. The square root of 84 is in the middle, so it goes next. And the square root of 121 is on the right, so it's the largest. We can also write this answer as a mathematical statement with 2 inequality symbols. What order should the numbers go in? Since both symbols are less than symbols, the numbers go in the same order as when we listed them from least to greatest. This shows that 8.731 ... is less than both of the other numbers, and the square root of 84 is only less than the square root of 121. It's pretty cool that even without knowing the exact value of some square roots, we can still compare and order them with other numbers. Even though I lost the swim race today, I'm excited about the new skills we've learned. We can compare different types of numbers, integers, decimals, fractions, and square roots, and using a number line was a great strategy to help us visualize them. While I keep practicing to get faster at swimming, you could keep working on ordering irrational numbers by finishing up your guided notes and then completing levels 1 through 3 of the online practice. Until next time, keep questioning, keep calculating, and remember, even if you don't know the exact value, clever comparisons will keep you afloat. See you next time.